So in this example, we will be using Ohm's law to find the voltage at this point, at this resistor, and at this resistor. So in this circuit, we have 30 volts. We have three resistors that have different resistances, and there's going to be a different voltage at each resistor. So because this is a single loop circuit, the current is going to be constant throughout the whole circuit. So we only need to be finding one current. It's one loop, one current. So the current here is going to be flowing throughout the entire circuit, but the voltages at these points are going to be different. The thing that we want is that when we find the current, we'll be using Ohm's law to find the voltage at this point, and if you add all of these voltages up, it should give you 30 volts with the constant current. So let's begin. So first we need to find the total resistance. So because the resistors are in series, we use this formula right here. So this is just the series equation. So the series law, we substitute these values in. So 500 plus 400 plus 600. If you add these up or put them in a calculator, it should give you 1500 ohms. Now be careful when you're solving equations like these, because if one of these was in kilo ohms, you'll need to convert it to ohm. So 500 plus 400 plus 600 together, that gives us 1500 ohms. Now to find the current, we will need to use V equals IR, so just the Ohm's law. Now to find current, we have to put on the other side, and that'll give us V equals R. Now if we substitute the voltage and resistance into the equation, that'll give us 30 over 1500, and that will give us 0.02 amps. That's a dot. Now, this is in volts, this is in ohms, the final answer is in amps. If you converted these to kilo ohms, this would be in milliamps, and the number will be larger because it's in milliamps. So to find the voltage at R1, so V1, we will need to do current times resistance. So the current is 0.02 time, multiply that by 500, and that will give you 10 volts. So the voltage at this point is 10. To find V2, we need to use the same formula, and the current is the same, 0.2, multiply that by 400, and that will give us about 8 volts. And to find the voltage at this resistor, so V3, we use the same formula, and we do 0.02 amps times by 600, and that will give us 12 volts. Now, you may have noticed something. If you add all of these up, that will give us 30 volts. So we know that this is correct because this is a series circuit, you can just add up the voltages. So this is just an example circuit. This is just showing how current is constant throughout the circuit, but the voltages around around each resistor is different. So as you may know, that if you were to build a circuit in real life and test the voltage at A, B, C, and D, you would probably notice that you're not getting the voltage that we calculated earlier in the video. So we know that the voltage over here is 10 volts, the voltage here is 8 volts, and the voltage here is 12 volts. So that's fine, but this is only across the resistors. So at point A, we know that we have 30 volts. So at A, right here, we have a voltage of 30 volts. So if we want to find the voltage across this point, we'll need to do 30 subtract by 10, because the voltage drop is 10 volts, and because it goes from positive to negative, so if it's going this way, is we're going to have to subtract by 10 volts. So at this point, we're going to get 20 volts. So point B is 20. So we know A is 30, B is 20. Now again, because this is positive and this is negative, we have a current going this way, and because it's from positive and negative, this is going to be positive to negative and it's going down, so we have a voltage drop of 10 volts. So earlier in the video, we also calculated this to be 8 volts. So this 8 volts is again from positive to negative, is going downwards, so we have a voltage drop of 8 volts. So from VB, so the voltage at VB, we do 20 subtracted by 8, so that's just 20 subtracted by 8, and that's just 12 volts. So the voltage at point C is 12, so the voltage right here, and we know that the voltage across this resistor, which also goes from positive to negative, we know that we're going to have to do 12 take away 12. Now, 12 take away 12 will give us 0, because the reason it's 0 and the reason why D is 0 is because at this point it's going to ground, so there's no voltage at this point, surely because it just goes to ground. So if there's no obstructions, no resistors, no nothing, it goes to ground and the voltage at point D would be 0.